Okay, in this video we're going to talk about demux. I tried to record this video originally and I really went into a lot of detail, really explained how demux works internally, and I realized it was just really just too much because I don't think the typical developer is going to need to know demux in that much detail to make it work. For now, what I'll say is demux is EOS's answer to Ethereum's events. If you're familiar with Ethereum development, you know when certain things happen on the blockchain, you can trigger events and listen to those on the client side and then update your user and let them know that some sort of event happened on the blockchain. With EOS, rather than using a push-based system, they're using a polling-based system. So your Node.js process in demux will just continually pull the blockchain and look for actions of a specific type and then update a database based on those actions. That's what demux is. Again, I'm going to spare you all of the nitty-gritty details here and just show you kind of what you're going to need to know to make alterations to demux. So first of all, let me just say this is the documentation right here. And I'm in the examples directory here, and there's this EOS transfers example. And what this example does is it just constantly listens for transfer actions on the EOS blockchain and then spits them out to the console. So let me show you that right now, right off the bat. So if I just run node index, you can see I'm here in this EOS transfers directory. And you can see what it's doing is it's updating the volume based on the EOS transfers. So anytime a transfer comes in, it will update the volume based on how much EOS was transferred at this time. And then you can see I'm also updating based on total transfers that I've been viewing since I've spun up the process. So I'm continuously just polling the blockchain, and anytime a transfer comes along, I'm updating this data based on that. So we'll investigate how all that's happening because it is non-trivial. I was going to start here in the index.js because that's the file that we're actually spinning up here. And what I'll do is I'll actually upload this example directory because I've just added a bunch of comments kind of explaining what each object is doing here and how it all ties together because it's very confusing. But I don't want to talk about that right now in the video because I think it will just overly confuse anybody. So unless you really want to see the nitty-gritty details, you can look up on my repo and pull this code down and read through the nitty-gritty details. But for now, just assume that it all works as you'd expect. So we'll start with this object handler, and it has to extend from the abstract action handler. Again, don't worry about that. The thing to keep in mind here, though, is the object action handler holds the state. So in the documentation, they mention that they pattern this off of React's Flux framework. Or sorry, it isn't React, is it? React is Redux. Okay, sorry. Off of React's Redux framework, which if maybe you're a React developer, maybe you know some React, maybe you don't. But the general idea is you have like this database of state essentially that just continually gets updated anytime something happens on the front end. It's almost like a NoSQL database on the front end. In this case, we're doing the same exact thing. So we're just going to keep updating the state. So what will happen is a new block will come in. We'll run through these updaters and we'll run through these effects that we pass into the object action handler. And so first of all, what we'll do is we'll update the state, and then after the state gets updated, the updaters will actually update the state, and then the effects will do something based on that new updated state. Again, just know that this abstract action handler that we're inheriting from takes updaters and effects as constructors. You don't see that here in the code at all. You'll see there's no constructor here. Just know that the abstract action handler actually takes those, so we can pass those in. So really, all this object action handler is really responsible for is maintaining the state. You also need to write these functions, but you can 9 times out of 10, I imagine, you would just leave these functions exactly the same way they are. You're not going to need to change those at all. But you are going to need to say, okay, you're going to need to at least store the index state. You can see here I have this comment right here. You have to store the index state, but aside from that, you can store as much data or as little as you want. In this case, we're storing the volume by symbol and the total amount of transfers. So that's our state, right? I'm going to actually close out of this file because we probably don't need to talk about it anymore. So this object action handler takes in these updaters and these effects. So if we look at the updaters first, you'll see that the updaters are just an array of JSON objects, and it's they take in the action type. In this case, we want the actions of transfers. So anytime a transfer action happens in this block, we want to run this updater on it. In this case, it's the update transfer data. Well, what is that? That's just a simple function here. And you'll see I make the point that all of these parameters have to be defined when you pass in a function here, down here, to actually update the state when the transfer action comes in. You have to take in all these parameters whether or not you're actually going to use any of them. In this case, you can see that the only one we're actually using is, oh, sorry, that's not true. We're using the payload and we're using the state. We're not using anything of the context, and we're not using any of the block info. But you still need to take these in as parameters. So what we're doing is we're parsing a token string. You can see that up here. It's just a simple utility function. You can kind of ignore it for now. Just assume that what it does is it spits out the, given the payload data.quantity right here, given that, it will give you back the amount in the symbol. In this case, it would be, let's say there was 10 EOS transferred from one account to the other, right? It would give you the amount here would be 10, and the symbol here would be EOS. So what this updater does is it takes in the payload, which is essentially the block data that's coming in, the payload that's associated with this transfer method, right? So it's just constantly listening to these transfer methods. It's getting this payload passed into it anytime a transfer method happens inside of a block. It's then parsing it out and then storing this in the state. So again, we talked about the object action handler maintains the state. That state gets passed into the updater as well. So we're able to update the state back in the object action handler right here. So that's what we're doing right now, is we're updating the state.volume by symbol. Let's actually open that back up. You can see here we have the state volume by symbol right here, and what we're doing is we're updating the state here. So we're saying, okay, if this symbol comes in and it's not one we've seen before in the state, we'll set that amount equal to whatever amount that transfer amounted to. Otherwise, we'll increase that amount, so now we know that there's a little bit more volume of EOS being transferred here, and then we'll update the state with the total number of transfers. So it's a very fitting name, right? Updaters. That's what all it's doing, is it's updating the state that's defined here in the object action handler. So after the state's been updated, what will happen is the object action handler will then eventually call the effects. Let me close out of this one. We'll eventually call the effects, which is again the same exact thing as the updater, is an array of JSON objects taking in an action type that they're going to act on, and then the function they're going to run on the action. So again, you're not going to see this anywhere in the code, but if you look up the abstract action handler, you'll see places where it calls the updaters, and then after it calls the updaters will update the state, and then the effects will be called immediately after that. So it's almost like a block comes in, we check with the updaters, we say, how do you want to update the state given this block that just came in? It will update the state, and then immediately after that the effects will go, okay, now that the state has been updated, what effect do you want this to have on your database? So here you can see the updaters got called, they updated the state, and now after that we're going to call the effects. We're going to effect on exactly the same action type as before. Previously we're updating based on the transfer action, and now again we're going to effect based on the transfer action. And what are we going to do when this transfer action comes in? Well, we're going to log the update, and if you see here, the function here is log update, and exactly the same way it has to take the same parameters whether it uses them all or not. In this case, all we're using is the state parameter. However, all of them are getting passed in. So this is a lot of stuff. Let's back up just slightly. So what this is used for, right, is you want to essentially store all of the state that you're interested in a database, right? Currently, the example they give is only printing things to the console. Like again, if we run this index.js code again, you'll see like it's just getting printed out. But there's no reason why you couldn't take this same exact data and store it in MongoDB database, or maybe a SQL database, or however you want to store this data. You can do that. You would just, rather than like logging the update, rather than calling log update here, you would actually interact with the database and then insert the data into the database. in much the same way, let's say maybe we were interested in transfers associated with only one particular username. So rather than having a state that holds volume by symbol, let's do maybe you would do volume by account name, and then you would just store anytime an account name had some sort of transferred in it, you would store how much EOS has been transferred to that account name. Let's say maybe you wanted to do that. Well, then up here you would parse the payload data slightly different. Rather than pulling out the amount and the symbol associated with it, you would pull out the account name and store it based on that. So that's, you know, just one way you would kind of update this code to do what you wanted. Really, you only need to worry about these three files. You need to worry about the state that you define here that you're eventually going to persist to a database. You need to worry about how you're going to update that state when the block comes in based on what data comes in, and then you need to store this data in a database here in the effects.js. That's really all that's happening in this this file. Again, I understand like this is very, very confusing. I will be more than happy to do a follow-up video on this if I get enough requests from viewers to do a follow-up video. I might even go through and do that. Maybe I'll do that account name example that I was talking about and show you exactly, you know, where I would change the code to make this happen. Maybe I'll actually persist the data in a database or something like that. But I'll hold off doing that for now. Anyway, I'll see you in the next video.